So here we go. Today we're learning about the Cartesian coordinate plane, specifically this one. This is practical applications of it. This is how cities are designed. New York City is based on this grid system. The only other version of it is like a circular looking thing. They're called polar coordinates. That's how some European cities are based. You can't really do numbers with European cities, like Fifth Ave, you know what I mean, like 34th Street. European cities are like names of streets, things like that. Right? It's very difficult. But okay, so you guys have seen this before? Yeah? What's this axis? What's this line that's running left and right called? Déjeuner. Yeah, it's called the x-axis. You got to label that up. And what's this one going up and down called? The y-axis. You're very smart. You know when you are graphing numbers, when you are graphing stuff, you always have to label the axis, especially on the regions. I can't even tell you the number of people who got a 64 and not a 65 because they missed this last point. Got to label it up. In fact, you also have to label these. 1, 2, 3, 4, all the way down. And you got to go -1, -2, -3, -4, -1, -2, -3, -4, -1. Oops, the top isn't negative. I made a mistake. It's 1, 2, 3, 4, and this is -1, -2, -3, -4. We've all done this, right? Okay, good. So, yeah. Now, we got to talk about a clown, right? A clown. I have no idea why this clown of a person decided to label the graph this way. I couldn't tell you. It makes no sense. It's just crazy. There's these things. They're called quadrants. Have you heard of them before? So they always ask you where a particular coordinate is located, and they don't necessarily want the number. They want what quadrant it's in. Do you know what quadrant this is over here? The first. Now, where is the second quadrant? Is it below it or to the left? Marlon. This is crazy. Who does stuff like this? Why? Makes no damn sense. You know what I'm saying? It's like one guy did it once one day, and then everybody else copied him there afterwards. Here's quadrant 3, and here's quadrant 4. You're going to have to know that, because I'll ask you where is stuff located, and I'm going to look for you to decide the quadrants. Are we good? Yeah? Now also let's talk. Let's chat. Suppose I give you a coordinate, 2, -3. That's how you see them. They're coordinates. Everybody is going to have to do this the same. It will never, ever, ever change. Which one comes first? The x or the y? Jacobo. The x, you're the man. It works just like the alphabet. The x always comes first. The y is always second. So if you wanted to plot that coordinate, 2, -3, here's what you do. 1, 2, down, 1, 2, 3. There it is. Did I do it right? Did I make a mistake? What do you guys think? No, I'm good. I think so. Yeah. But thanks. I appreciate it. Sometimes I make big mistakes. So what do you think? You done this before? This is good? Nice. Flip over that page. So we're given some points on our piece of paper. We're going to write them down. We're going to plot them. That's all I want you to do. Plot those points. Oh, on your paper, you don't have the grids. All I did was try and give you a little sheet. You know what I'm saying? Not everybody. We don't have enough graph paper to give out to everybody, so I tried to make it small. Do your best. I understand you can't label each one of them, like 1, 2, 3, 4. So on this diagram, you might not be able to get that in, but you certainly need to draw these lines over here. Draw in the axes. Okay. So here are the coordinates that we need to draw. All right. So here's our points, right? Let me just label my axes because I can do that. Let's do C first. Over 4. 1, 2, 3, 4. Down 2. 1, 2. There's C. B, going to go up 1. Over 1, 2, 3, 4, 5. There's my man B. And A is back 3. 1, 2, 3. Down 2. 1, 2. There's A. And I have room, so I should be labeling these. And then I'm going to connect it. What kind of shape do we have? Nice. Yep, got a triangle. Okay, so we plotted down all our points, and now we got to find the area of a triangle. Does anybody know the formula? No? Nobody knows it? How about this? Ever see this one before? 1/2 base times height. You guys have never seen that before in your life? You guys have never seen that before in your life? You have? Tiana, what do you think, girl? You saw that? Okay. Here we go. So the problem is what is the height? What is the base? The base is this distance right here. How many units is that? Count them. Nope. 7. The base equals 7. All we did was literally count. 1, 2, 3, 4, 5, 6, 7. Just the number of spots. Now, let's count the height. The way you find the height is there's the base. You have to take one of the points that's drawn above it and drop a line straight down. You can't go anything but straight. Straight down. This is the height. How much is the height? Yeah. So now we're going to take these two numbers, we're going to plug them into our formula. We're going to find the area of our triangle. The area of our triangle is going to be 1/2 base, that was 7, height, that was 7. Who can do this? We got no calculators out. We can do this kind of math in our head. 49 times 1/2. That's the same thing as doing 49 divided by 2. What's 49 divided by 2? 20 something, yeah. 24.5. Now, do we know what kind of things we're measuring? Feet, inches, miles? Nope. And who said these were feet? Look at these tiles. They could be little itty bitty tiles in a bathroom, or they could be, you know, like measurements on land, miles long. Nope, we don't have any units. So we're going to leave it as just units. Squared. Because that little squared thing on top says what kind of shape it is. Square. Whoops. Let me go back for a minute. My bad. Let's talk about a few things that everybody should know. If somebody asks you for the perimeter of an object, talk to me. What is the perimeter? How would you describe it? The outside. It's like how much fence would I need? So the perimeter is the sum of all the sides. You know, because that's going to pop up. Perimeter, sum of all the sides. I want you to, either you know that in your head or you should write it down. Yeah. There are 3 area problems that if you know them, you could solve any problem. Area of a rectangle. Area of a rectangle. Does anybody know what area of a rectangle is? Like what the calculation for is it? Everybody in here knows what a rectangle looks like, right? No? A rectangle looks like this. Yeah, excellent. It's length times width. Absolutely, length times width. Now, there are very special, rare rectangles. Rare rectangles. I'm talking about, they are the diamonds of all rectangles. Guess what they're called, Julian? Yeah, they're squares, because they're so rare. How do you calculate the area of a square? Why are squares so rare? Because, Joe? All the sides are the same. They are an equilateral rectangle. Since all the sides are the same, it's just going to be side times side. And another way that you could say that is that you are doing the side squared. And then finally, we have the area of a triangle. I'll just put it down like that. Area of a triangle we talked about. Area of a triangle is 1/2 base times height. Yep. If you know all three of these, you can solve any type of problem pretty much that I give you, with the exception of a circle. Any type of problem, like even a shape like this. You know what kind of shape this is? Ooh, who said that? Trevon, you're a very smart man. Very smart man. That is a pentagon. Pent, meaning 5. How do you calculate the area of this? Cut it up. Cut it up. Look at what it is. This weird looking shape is actually just comes from combining a triangle and a rectangle. So that's how you can be cheap. You know? You don't have to know every formula. You can do a lot with a little.